This presentation is part of a series of videos for biostatistics using Minitab. Dr. Wooten explains the meaning of probability, its properties, and how it is used to calculate expectations, moments, and variance. To express these findings in a shorthand, see the following nomenclature. Probability is a measure between 0 and 1 with respect to the events within a sample space. A probability of 0 represents an impossible event, and a probability of 1 represents a certain event. The sample space is the set of all eventualities to be considered. A partition of the sample space is a finite number of pairwise disjoint subsets that, in union, create the sample space. There are 3 truisms. First, the probability of the sample space is 1. Second, the likelihood of an event within the sample space is positively defined and bounded between 0 and 1. And third, the probabilities associated with any partition of the sample space must sum to 1. Empirical probability is the partial count of elements within an event in ratio to the sample size. The additive properties distinguish between overlapping sets and disjoint sets. The multiplicative properties distinguish between dependent events and independent events. When associated with quantitative measurements, these measured likelihoods can be used to generate estimates for the mean, expected value, and other moments within the data to variance and deviation. Using these definitions, it can be shown that in expectation, a constant additive to a variable is the same constant value added to the expected value of the variable. In expectation, a constant multiple of a variable is the same constant multiple of the expected value of the variable. In variance, a constant additive to a variable does not vary, adds nothing, 0, to the variable's variance. However, in variance, a constant multiple of a variable is the square of the constant multiple of the variable's variance. These manipulations show that the expected value of the sample mean is the actual mean of the data, and the variance of the sample mean is the standard variance of the sample mean divided by the sample size. Thus, the standard error, the standard deviation of the sample mean, is the standard deviation divided by the square root of the sample size. Using substitution, the normal probability density function can be transformed and simplified to functions whose areas under the curve are equivalent and whose properties are inherently passed along, generating additional probability distributions. The chi-square probability density function manipulates the normal distribution, creating a positively defined probability distribution by measuring error squared, effectively doubling the probability by symmetry. Based on the sample size, these first 2 probability functions give rise to the t-distribution. 2 chi-square distributions, taking 2 in ratio, result in the f-distribution. For the confidence interval, the observed sample mean estimates the central tendency probabilistically to create confidence limits, assuming the normal sampling distribution. Based on the fundamental probability structure and the degree of confidence, the inverse probability yields the critical statistics between which the parameter of interest lies through algebraic manipulation. Confidence limits can be determined for the population parameter. Hypothesis testing. For example, when testing the sample mean, the probability distribution is used to measure the p-value, that is, the probability determined by the test statistics. The p-value is then compared to the preset level of significance or alpha risk to make a data-driven decision regarding the null hypothesis.